In this video, we are going to discuss blood physiology. Right, so blood is actually a connective tissue in liquid form. It is considered a fluid of life because it carries oxygen from lungs to all parts of the body and carbon dioxide from all parts of the body to the lungs. It's also known as a fluid of growth because it carries nutritive substances from the digestive system and hormones from the endocrine glands to all the tissues. Blood is also known as a fluid of health because it protects the body against the diseases and get rid of waste products and unwanted substances by transporting them to the excretory organs like kidneys. Right, so let's talk about some properties of blood. The first property I want to talk about is color. Right, so blood is red in color. Now, there is a difference between arterial blood and venous blood. Arterial blood is scarlet red because it contains more oxygen, and venous blood is purple red because it contains more carbon dioxide. The second property is volume, blood volume. Right, so the average volume of blood in a normal adult is about 5 liters. In a newborn, the volume is around 450 mils. It increases during growth and reaches 5 liters at the time of puberty. In females, it is slightly less and is about 4.5 liters. Blood volume is about 8% of the body weight in a normal young healthy adult weighing about 70 kilograms. Another property which is very important is blood pH. Right, so blood is slightly alkaline and its pH in normal conditions is 7.4. The next property is viscosity. Blood is 5 times more viscous than water, and it is like this mainly because of red blood cells and plasma proteins. Specific gravity is another important property. Right, so the total specific gravity of blood is 1.052 to 1.061, right, for total blood. And then gravity of blood cells, 1.092 to 1.101. And specific gravity of plasma is 1.022 to 1.026. Right. Okay, so blood is two main parts, plasma and formed elements. Right, so let's start with the plasma. Right, so plasma is actually a straw-colored clear liquid part of blood. Right, so we can divide it into 3 parts. Water, which covers about 92 to 93%. There is solid, which covers 7 to 8%, right? And we also find gases, right? So let's start with the solid part, right? So the solid part of a plasma can be divided into organic substances and inorganic substances. Organic substances include plasma proteins first, and there you find albumin, globulin, fibrinogen. We also find amino acids, right? So amino acids are the monomers of proteins, and they are divided into essential amino acids and non-essential amino acids. We also find carbohydrate, and glucose is the main important source of energy, right? Okay, we find fats also, and you have these classes here: triglycerides, cholesterol, phospholipids. Then we also find hormones. Enzymes found in blood include amylase, carbonic anhydrase, acid phosphatase, alkaline phosphatase, lipase, esterase, protease, and transaminases, right? And we also find a non-protein nitrogenous bases, right? Non-protein nitrogenous bases like ammonia, creatinine, xanthine, hypoxanthine, urea, and uric acid. And we also find antibodies. Right, so that is the organic substances. Inorganic substances, you find sodium, calcium, potassium, magnesium, bicarbonate, chloride, phosphates, iodide, iron, and copper, right? And then lastly, about gases. Three main gases you find in blood are oxygen, carbon dioxide, and nitrogen. Right, so that's plasma. Right, so the other part is formed elements, and these are actually red blood cells or erythrocytes. That's number one. Number two, white blood cells or leukocytes, and number three, platelets or thrombocytes. Okay, so these are some of the things which I mentioned, right, and their normal value, right? So glucose, you find it around 100 to 120 milligrams per deciliters. Creatinine, you find it around 0.5 to 1.5 milligrams per dl. Cholesterol is usually up to 200 milligrams per dl. Plasma proteins from 6.4 to 8.3 grams per dl. Bilirubin from 0.5 to 1.5 milligrams per dl. The list goes like that. Right, okay. Right, so there is another important thing called hematocrit, right? So to understand this term, let's say you take blood, you put it in a test tube, and then you put a suitable anticoagulant, and then you centrifuge, right? So the result will be like this. There will be three components: the upper part, the middle part, and the lower part, right? So more dense one are erythrocytes, and then less dense you find plasma, and in between you find a Buffy coat, right? So erythrocytes are normally is about 45% of total blood, and plasma is about 55% of total blood. And then the Buffy coat, which contains aggregates of leukocytes and platelets, is usually less than 1% of total blood, right? So the volume of red blood cells expressed in percentage is called the hematocrit or packed cell volume or PCV, right? So in this case, I just said it's around 45%, but it's different in males and females. We'll talk about it later. But let's talk about a variation between this ratio, okay, specifically hematocrit, right? So if you look here, in anemia, hematocrit will be decreased. You can see here the percentage of RBCs is very low. And another case, polycythemia, you can see that the hematocrit is elevated, right? Okay. Then another important thing is called the serum. What is serum? Serum is a clear straw-colored fluid that oozes from a clot. When the blood is shed or collected in a container, it clots And in this process, the fibrinogen is which is soluble is converted into fibrin, which is insoluble, and the blood cells are trapped in this fibrin, forming the blood clot. After about 45 minutes, the serum oozes out of the blood clot. The volume of the serum is almost the same as that of plasma, that's around 55%. It is different from plasma only by the absence of fibrinogen. That is, a serum contains all other constituents of plasma except fibrinogen. Fibrinogen is absent in serum because it is converted into fibrin during clotting. Right. So in conclusion, what is serum? Serum is equal to plasma minus fibrinogen. Okay, now let's just review the functions of blood, right? We're going to talk about 9 main functions of blood. Nutritive function. Nutritive substances like glucose, amino acids, lipids, and vitamins derived from digested food are absorbed from the gastrointestinal tract and carried by blood to different parts of the body for growth and production of energy. Respiratory function. Right, so blood transport respiratory gases. Right, it carries oxygen from the alveoli of the lungs to different tissues, and it carries carbon dioxide from tissues to alveoli. Right. Excretory function. Waste products formed in the tissues during various metabolic activities are removed by blood and carried to excretory organs like kidney, skin, liver, etc. for excretion. Transport of hormones and enzymes. Hormones, which are secreted by ductless endocrine glands, are released directly into the blood. The blood transports these hormones to their target organs or tissues, and it also transports enzymes. Regulation of water balance. Water content of the blood is freely interchangeable with the interstitial fluid. This helps in the regulation of water content of the body. Regulation of acid-base balance. Plasma proteins and hemoglobin act as buffers and help in the regulation of acid-base balance. Regulation of body temperature. Because of the high specific heat of blood, it is responsible for maintaining the thermoregulatory mechanism in the body, that is, the balance between heat loss and heat gain in the body. Storage function. Water and some important substances like proteins, glucose, sodium, and potassium are constantly required by the tissues. Blood serves as a ready-made source for these substances, and these substances are taken from blood during the conditions like starvation, fluid loss, or electrolyte loss, etc. And last but not least, defense function. Blood plays an important role in the defense of the body. The white blood cells are responsible for this function. Neutrophils and monocytes engulfs the bacteria by the process of phagocytosis. Lymphocytes are involved in the development of immunity. Eosinophils are responsible for detoxification, disintegration, and removal of foreign proteins. Thank you so much. If you like this video, please give it a thumbs up. And if you feel that we are uploading helpful videos, you are free to subscribe so that you won't miss any of our latest videos. Until next time.